section 1.7 is about solving equations. And so we have two objectives. One would be to solve equations by trial, and then we solve equations such as t plus 28 equals 54, or 28 times x equals 168, or 98 times 2 equals y in a more systematic way. First of all, what's an equation? Well, an equation is a statement that two expressions are the same. For example, if you look at this one, t plus 28, z equals 54. The question is, what is t in this case? So we begin by looking at solutions by trial. And so when we look at exercise number 1, the question is, find a number such that each sentence is true. So the question is, what number do we have to add to 1 to get 8? Well, I think most of you can probably figure that one out, and that would be the number 7. So 7 would be the answer. Or in this case, what number what number do we have to add to 2 to get 7? Well, you think about that for a little moment, and you say, well, we could try different numbers like 2 and 3 and 4 and 5 and 6 and so on, and then we find, 5 plus 2 equals 7. So that's what's meant by finding solutions by trial. Here it's the other way around, and that is here we're to determine whether 7 is a solution of blank plus 5 equals 9. So in other words, what we're supposed to do here is we are supposed to replace the blank spot with the number 7. So the question is 7 plus 5 equal to 9? Is that a true statement? Question mark. Well, we know that 7 plus 5 is 12, and 12 is not equal to 9. So in other words, 7 is not a solution of this equation. Is not a solution. Similarly, in number 4, we are asked, determine whether 4 is a solution of the equation blank plus 5 equals 9. So in other words, here we replace the blank spot with the number 4. So that then becomes the statement or the sentence 4 plus 5, in other words, this 4 now goes in the blank spot, is that equal to 9? Well, 4 plus 5 is 9, and 9 equals 9. Therefore, we can say that 4 is a solution. 4 is a solution of the equation. So here's the official definition. A sentence with an equals sign is called an equation. A solution of an equation is a number that makes the sentence true. Therefore, 6 is the solution of the equation 9 plus 3 equals blank, because 9 equals 3 plus 6 is true. However, 7 is not a solution of that same equation, because 9 equals 3 if we replace the blank spot with 7. 3 plus 7 is 10, and 9 is not equal to 10. So therefore, that would be false. Therefore, 7 is not a solution of this given equation here. And so in general, we can use a letter in an equation instead of a blank. For example, we can say, well, 9 equals 3 plus n, where n is again is a letter or variable. And so now we have to determine what n is equal to. And as we found out already, if n equals 6, then that makes it a true statement. So n equals 6 is a solution. So n is called a variable because it can represent any number. Here's an important sentence. If a replacement for a variable makes an equation true, the replacement is a solution of the equation. So any number that makes that a true solution, make that a true statement rather, is called a solution. So in general, we can talk about solutions of an equation. A solution of an equation is a replacement for the variable that makes the equation true. When we find all the solutions, we say that we have solved the equation. Okay? So in other words, to find the replacement value for the variable, once we find all of them, then we have solved the equation. So here are some exercises. They're supposed to be solved by trial. So here the question is n plus 3 equals 8. So we can think about different replacement values for n, like 1 plus 3 is 4, so that's not equal to 8. If n equals 2, 2 plus 3 equals 5, and 5 is not equal to 8. Then we can go to n equals 3, 3 plus 3 is 6, so that wouldn't be equal to 8 either. And if n is equal to 4, then 4 plus 3 is 7, that's not it. But when n is equal to 5, we know that 5 plus 3 is equal to 8, so n is equal to 5. And typically, you really have to try out all different combinations. In most cases, you can already see it. Here we're looking for number x, where when subtract 2 gives us 8. And so if you give that a little bit of thought, it's probably not too hard to think about that x has to be, first of all, it has to be greater than 8 because we are subtracting 2. So we can just begin maybe with 12, and 12 minus 2 is 10, so x could not equal 12. If x is equal to 11, then 11 minus 2 is 9, so that isn't it. But if x is equal to 10, then 10 minus 2 is indeed equal to 8. So we can say in this case the solution is x equal 10. X equals 10. Here we have a simple division problem. 45 divided by 9 equals y. Well, whether you do it longhand or use a calculator, we know that 45 divided by 9 equals 5, so that quotient equals 5. So then y equals 5. It's simply a division problem. In number 8, we are asked to find t when 10 plus t equals 32. So, we can think about that a little bit. And if t were equal to 20, then 10 plus 20 is 30, so maybe a little more like 22. And 10 plus 22 is indeed equal to 32. So in this case, we can say that t equals 22 is the solution of the equation. And if these things are a little bit of a mystery to you, first of all, go over these examples again. And also, I would certainly recommend to do additional exercises of this type in section 1.7 in the exercise, drill exercise section. And that's on page 52 and 53, pages 52 and 53. So they can practice these type of these kind of problems. So now we are talking about solving equations systematically when they're in the form x plus a equals b. We want to find out what x is. Okay, and it's very simple. To solve x plus a equals b equations of this type, simply subtract a on both sides. That's it. So it's not very complicated. And that's the good news. And as a principle, what we want to do when we solve any equation, we want to isolate the variable. Like in this case, x, or in the previous examples, we had n or t. Whatever the variable is, we want to isolate it. So it's on the left side, we have the variable. On the right side, we have whatever the replacement value is. So that is the objective when we solve an equation, isolating the variable. And so in this case, when we subtract a on both sides, then we isolate x. So let's look at some examples here. Let's look at number 13. We have a guided example. So in the guided solution example, we have the equation x plus 9 equals 17. And as was suggested in the general statement about how to solve this type of equation, we subtract a on both sides. So in this case, a is equal to 9, so we subtract 9 on both sides. So 9 minus 9 on the left side and 17 minus 9 on the right side. Now 9 minus 9 is 0, and x plus 0 is still x, and 17 minus 9 is 8. And now we check to see if that is true. So now we go backwards. We have x plus 9 equals 17. We replace x with the number 8. And we ask ourselves, 8 plus 9, is that equal to 17? Well, 8 plus 9 is 17. And since 17 is equal to 17, since this is true, the answer checks. So the solution is x equals 8. In exercise number 14, 77 equals m plus 32. Again, to isolate the variable, we subtract 32 on both sides. So we have m plus 32. So now we subtract 32 on both sides. So that's on the right side, and then on the left side we have 77 minus 32. So here we subtract 32 on both sides. So then on the left side we get 45. And on the right side we have m, and 32 minus 32 is 0, and m plus 0 equals m. So the solution is equal to 45. Similarly, for number 15, oh, by the way, we can check the answer. We look at the original equation, 77 equals, and now we thought that m is equal to 45, so 45 plus 32. And what is 45 plus 32? Well, it's equal to 77, and that is a true statement. So therefore the solution is equal to 45. And then for number 15, 155 equals t plus 78. So to isolate t, we need to subtract 78 on both sides. So on the right side we have t plus 78 minus 78. And then on the left side we have 155 minus 78. And so 155 minus 78 is 77. And on the right side we have t plus 78 minus 78, and that's equal to 0. So in other words, t equals 77. So that is our solution to this equation. And again, we can check the answer very easily because we ask ourselves 155, so that's a check. 155, is that equal to 77 plus 78? When we replace t with 77. And since 77 and 78 is equal to 155, so we can say that 155 equals 155, so that is true. So we can claim that 77 is the solution of this given equation. Number 16 has the equation 4,566 plus x equals 7,877. So what we need to do on both sides to isolate x, we need to subtract 4,566 on both sides. So on the left side we get 4,566 minus 4,566 plus x equals 7,877 minus 4,566. The important thing to remember is when we subtract a number on one side of the equation, we also need to subtract it on the other side of the equation. So on the left side, we have 4,566 minus 4,566, which is 0. And then we only have x left, so x equals, and 7,877 minus 4,566 is equal to 3,311. So that is our solution. And we can check the answer, and that is, we add, well, we replace x with the number 3,311, so then 4,566 plus 3,311, is that equal to 7,877, and since this is a true statement, that's 7,877, and that equals 7,877. That is true. So the solution of this equation is 3,311. When we look at number 17, to isolate h, the variable, we need to subtract 2,058 on both sides. So then on the left side we have 8,172 minus 2,058 equals h plus 2,058 minus 2,058. So then on the left side we get 6,114, and on the right side we only have h left because 2,058 minus 2,058 is 0, and h plus 0 is h, so that's our solution. Now we are supposed to check the answer, and we do that when we look at the original equation and we ask ourselves, is 8,172 equal to, when we replace h now with 6,114, we simply replace that with this value here, plus 2,058. Well, when we add these two numbers, 6,114 plus 2,058, that is 8,172. So in other words, the two sides are the same. So that's a true statement. So the solution of this equation is equal to 6,114. H equals 6,114. So these are the calculations for number 17. The second type of equation looks like this. A times x equals b. And to solve that type of an equation, a times x equals b, we divide by a on both sides. Okay? So let's look at number 18. 8 times x equals 64. According to the solution suggestion is we need to divide by a. So in this case, a is the number that multiplies the variable. In this case, that's equal to 8. So in other words, we have 8 times x, and we divide that by 8, because that is the number that multiplies x. So divide by 8 equals 64 divided by 8. So on the left side, 8 divided by 8 is 1, or the 8's cancel, so to speak. So we have x remaining, and we know that 64 divided by 8 is equal to 8. So that then seems to be our solution. Now the way we check this is we multiply. We replace a, in this case 8, with x. So then we have 8 times 8. We replace an x with 8. Is that equal to 64? Is that a true statement? And since 8 times 8 is 64, we can say yes, that's a true statement. So then the solution of this equation is 8. And here's a guided solution. We simply follow the steps as suggested. So here we have number 19, 144 times 9 equals 9n. And so here 9 is a number that multiplies a variable. Therefore we divide by 9 on both sides. So, and on the right side we get 9 divided by 9, which is equal to 1, or equal to 1 times n, which is n. And 144 divided by 9 is equal to 16. And then we check. Is 144 equal to, well, 144 equals 9 times n, and when we replace n with 16, is 144 equal to 9 times 16? And since 9 times 16 is equal to 144, we conclude that since 144 is equal to 144 is true, the answer checks, and the solution is 16. So in a similar way, we look at number 20, but 5,152 equals 8t. So here the number that multiplies t is 8, therefore we need to divide both sides by 8. So we divide 5,152 by 8 on the left side, and on the right side we have 8 times t divided by 8. And so 5,152 divided by 8 equals 644. And the 8's cancel, so that's equal to t. And we can check the answer by replacing t with the number 644, since we think that's the solution. So then the question is 5,152 equal to 8 times 644? And since 8 times 644 is equal to 5,152, that's a true statement. So the solution of this equation is 644. And with the previous examples, or previous type of equation, if this is challenging to you, first of all, I'll go over the examples that I did for you. But again, I would also recommend to do additional drill exercises that you can find on pages 52 and 53 in the textbook. Number 21, it says 18 times y equals 1,728. Since 18 multiplies the variable, we need to divide by 18 on both sides. 1,728 divided by 18. So this isolates our y. And when we divide 1,728 divided by 18, we get 96. Whether you use long division or a calculator. And then to check the answer, we replace y with a value of 96 in the original problem statement. So the question is 18 times 96 equal to 1,728? And since 18 times 96 is 1,728, this makes it a true statement. That's true. So therefore we can say that the solution is 96. And number 22 works in much the same way. N times 48 equals 4,512. And so here we need to divide both sides by 48, because 48 is a number that multiplies a variable. So n times 48 divided by 48 equals 4,512 divided by 48. So then on the left side we've isolated the variable n, and on the right side we get 94. Again, you can use long division. That's why we practiced that in the previous sections. But here we just have the answer. And now we check our answer. And we ask if we replace n with 94 in the original equation, is 94 times 48, would that make it a true statement? Is that equal to 4,512? Well, when you multiply 94 times 48, you get 4,512. That, of course, is equal to 4,512. So that's the correct answer. So in other words, the solution of this equation is 94. And this concludes section 1.7.